this was problem 272. I wasn't quite paying attention just now. I was trying to work on the next problem. But the problem was let a sub 1 equal 1 minus 1/2, a sub 2 equals 1/2 minus 1/3, a sub 3 equals 1/3 minus 1/4. And the first part of the question was to find the formula for the nth term of a sub n, which is this sequence here at the top. Which if you just look at it intuitively, you can tell that it's just 1 over n minus 1 over n plus 1. Which is, you can just plug in the numbers and figure it out. And then it says compute the limit of a sub n. So I just took the limit, plugged in infinity, and the limit goes to 0. The third part of the question was to find a formula for the nth term of the series S of n, which I got all my numbers here. I just basically simplified it. So 1 minus 1/2 is 1/2 for S of 1. S of 2 is 1/2 plus the second term. Is that right? Okay. So it's 1/2 plus 1/6, which is 2/3, and I went up to S of 4, and looking at my simplified, terms for this series, I came up with the formula n over n plus 1. And you can plug in numbers to see if it satisfies. And then the last part was to take the limit of this series formula. And I plugged in infinity. They both went to infinity, so I used L'Hopital's rule and took the derivative, and it came out to the limit of 1. Any questions?
Questions for him? Sure, Kyron, you good?
Yeah, I'm good. I don't believe everybody would go.
Did I not explain it?
No, yeah, it's good. I understand.
All right, no questions. He's good. You believe that? You believe it? Is this a formula for each term? Does it work? I put 4 in there. I get 1/4 minus 1/5. Should that be the next one? Yeah. There's one dangerous thing here. This is another one of those indeterminate forms. 0 minus 0. I can never remember if that one always goes to 0. So I'm gonna suggest something. It's 1 over n minus 1 over n plus 1. So I'm gonna check your work. I'm not saying it's incorrect. I'm just gonna check it. We get a common denominator. N plus 1 over n times n plus 1 minus n over n times n plus 1. With me? Limit as n goes to infinity of n plus 1 minus n is just going to be 1 over n times n plus 1. All right, now I'm definitely in agreement that he's right. The bottom's getting bigger and bigger and bigger. The top's staying constant. But I always worry about something like 0 minus 0 or infinity minus infinity. Like, suppose I had infinity minus infinity was x squared minus x, or the limit as x goes to infinity of x minus x squared. This is going to infinity, right? This one's going to infinity. Well, what's the whole thing going to?
0.
Let's see, x squared minus x. Parabola goes through 0, goes through 1, looks like this. So what's that going to as x goes to infinity? Infinity, right? This one is what's the difference? It's the other parabola, isn't it? It's that one flipped over. So it's still going to infinity minus going to infinity, right? But it's negative infinity. Just always worried. If you're adding or subtracting infinities, or you're multiplying infinities or zeros, Always be very, very, very nervous. That's how engineers blow up space shuttles. I'm lucky. I can make a mistake at the board and get away with it because y'all just correct me, right? But you make a mistake in the coding for a bridge or something, and you multiply infinity times 0, and you assume it's 0. It might be infinity. You got to be really, really careful whenever you're multiplying, adding, or subtracting with infinity. Okay, so I'm just double checking. I agree with you. You were right. I swear I think there are examples, and I don't know why I can't come up with one off the top of my head where you got 0 minus 0 and it doesn't come out to be 0. Okay. So did he write down the proper formula? When S1 is 1 minus half, so it's a half. S2 is it's going to be that 1/2 plus the 1/2 minus the third, which is 1/6. He did a lot of this in his head, right? And the next one's a half plus the first two. So we kind of have to trust him there.
Yeah. Second thing.
Yeah? Andrea, question?
Question on termination, I guess, the terminology. With the S of N, can you explain that series symbol thing with the N and then the...
Yeah, the S sub N means sum from little n equals 1 to big N of A sub N. This just means you plug in this one, you plug in the next one, until you get to the top one. We call it the nth partial sum because you're summing up the first n terms, right? And that's what he did. This is A1. This is A1 plus A2. This is A1 plus A2 plus A3. This is A1 plus A2 plus A3 plus A4. And that's the most important thing I want you to remember is this series. When we write this doesn't make sense. You can't add up infinitely many numbers. Go home and try it.
That's the limit.
When you get tired, say, okay, this must mean something else. And it means the limit of the partial sums. That's the most important thing to remember about series. It really means a limit. And then, so if we could find a formula for this, like we did on the backboard, we can always figure out what this is. And he found a formula for the nth partial sum, and it's easy to see what the limit of this is, right? It's not easy to see what adding all those terms up does, is it? I mean, in fact, that's a weird series. If you start writing the terms out, it says 1 minus a half plus a half minus a third plus a third minus a fourth plus ... Right? If I just write it out. Sum n equals 1 to infinity of 1 over n minus 1 over n plus 1. Right? If I were to write down the proper notation here, that's my A sum n's. But look what happens. What actually happens? A lot of stuff cancels, right? You can kind of see why it turns out to be 1 if you look at it like this. So you can see that one makes sense. And that's what I wanted to start you off with, some that are really simple, that really make sense, that even if you write out the terms, you can see what it is. So you can see this one's definitely going to 1. The nth partial sum never makes it quite to 1 because you're always subtracting something, aren't you? Like, see, if even though these are zeros, I still have a minus 1/5. If I did the first A1, A2, A3, A4, then what did he get for the S4? He got 4/5, didn't he? 1 minus 1/5. That's where that 4/5 came from. Okay, so what am I asking you to do on the next ones? On each of the next ones, I'm asking you to do exactly what they did on these first two. And there is a formula, and we will learn it, and somebody will prove it. Raven's really close to understanding the proof. But you want to first write out a formula for the nth term, then you want to try to write out a formula for the nth partial sum. Then you want to try to figure out what the limit of that is. Yes, there's a formula that you can plug in. It is an important formula. You use it in business to find interest. In fact, the only important problem you're going to work in your whole college career, the whole time you're here, you're going to work one important problem. 4 years, well, 6 for most of them. But the whole time you're here, you're going to work one important problem. It's number 277. All right, stay off the streets. It tells you how much to invest to get rich.